this example that I'm going to walk you guys through is related to section P4, and it's very similar to the two questions that are at the end, the very last two questions on your P4 handout that we've done for homework. This is definitely a problem that I have seen give students lots of issues in the past, and it really isn't that bad. I think the main thing is we just need to understand what it's asking us to do. So I am asking you to find the equation for the line that is the perpendicular bisector. So we're going to talk about that in a minute. We need to know what it means to be a perpendicular bisector. And it's going to be the perpendicular bisector of a line that passes through these two ordered pairs. Now I've already gone ahead and plotted these two ordered pairs just to give you a visual of what this might look like. So I'm going to go ahead and put a line through these 2 points. You maneuver it here a little bit. And then let's make these colors show up pretty good. There's 1 point, there was the other. So folks, the perpendicular bisector between these 2 points, perpendicular meaning it would form a 90-degree angle, bisector meaning it's going to cut straight through the middle of these 2 points. So let's pretend the middle is about right here, and then, whoops, try that again. Middle being here, and then perpendicular, approximately something like this. So folks, this is the equation we need to create for this line right here. So I would say there's a couple of first steps. Number one, in order to write an equation of a line, we need the slope. So slope is probably going to be our easiest piece, and if you remember from our problem set in class, perpendicular slopes are opposite reciprocals to each other. So if we can find the slope of this line, which since I've given you 2 points, we can then find its opposite reciprocal and we would have our slope. So let's go through that work. The slope of the line I've given you, subtract the y's on top, subtract the x's on the bottom in the same order. This gives us a -2 over a -3. So our slope is a +2/3, which makes the slope of our line, the slope of the perpendicular line, a -3/2. So that's crucial information number one. We need the slope of our line. In order to write an equation for our line, we need to know a point that is on our line. That point, folks, is that middle point between the two endpoints you are given. In other words, you need to use your midpoint formula. So let's go ahead and calculate the midpoint. Midpoint, we add the x's, divide by 2, add the y's, divide by 2, and then 12 over 2 is 6. So it looks like our midpoint is 1/2, 6. This is critical information number 2. Once you have a slope and a point, folks, you can go ahead and write an equation. I tend to start my equations in point-slope form when I have this information. It seems very easy. Y minus the y value of my point equals my slope times x minus the x value of my point. Now from here, I could get it into whatever form I wanted. Let's say I maybe wanted slope-intercept form. I'll go ahead and distribute my -3/2. And then I am going to have to add a 6 over. So y equals -3/2 x. And then let's see, off to the side I might go ahead and calculate 3/4 plus 6. I'm going to need a common denominator of 4 here, so that ends up being 24 over 4 as opposed to 6. So that gives me 27 over 4. and this would be your answer in slope-intercept form. Now, if you needed to go ahead and get it into standard form, we could go from there, but again, I'll stop with the slope-intercept form for now, hoping that you would be able to get standard form on your own if needed. If not, just ask in class and we can talk about it. But again, that goes from given two endpoints, finding the perpendicular bisector equation for those two endpoints. We first found the slope, used the opposite reciprocal. We then found the midpoint, and we used that point as a point on our line, and we went ahead and started setting up our form. Hopefully that helps.